Welcome back. As I promised you before, I'm going to make a video about the Elisa method. But before we jump in, let's talk about just briefly about the Elisa. The Elisa is a method what we're using in molecular biology and also in the, for example, like those labs which are making for you the test that you pay for, like an antigen test or a pathogen titer, or let's say if you just want to go to see which kind of STD you had. So the ELISA is a well-used method, and the name comes from the enzyme-linked immunoabsorbent assay. In that sense, you can use like the part of the pathogen, the antibodies that it is circulating in your blood. So there are a lot of options to measure, and the method is going to work in a 96-well plate every time. The difference between the ELISAs are the way that the protein is going to bind to the antibody. So there is the first one, which is the so-called direct ELISA. In that sense, the protein of interest, which can be a virus, a bacteria, a protein, whatever, it is going to immobilize to the surface of the well, and there would be one antibody which is going to attach to it. And on that antibody, usually there is an HRP, which is the horseradish peroxidase. And if you give the substrate, it gives you the colorful product. The second one is a so-called sandwich ELISA, in which there is a, as you see, the figure clearly shows that this is a sandwich. There are two antibodies there, and in the middle you will find the protein of interest. There's another one which is called indirect sandwich ELISA. Here we are using three different antibodies, but the method is almost the same. Also, you have the so-called streptavidin-based ELISA. This is really strong in a sense that the streptavidin, these three parts which I marked here, this is the streptavidin and the biotin connection, and also an HRP. And there's another type of ELISA, which is the so-called sandwich competitive ELISA, in which there's a colorful product there, and there's a competition between the protein of interest and the colorful product. So in that case, if you do not see any color changes, it means that you have a lot of from this one. So in that case, there were less of the protein of interest. Whatever you do, every time the method generates for you a colorful product, as you see on this figure. And also it is important to see that even more blue for the traditional ELISAs, except the competitive one. For example, here this blue is really, really high level, showing that there are a lot of particles in it. If you have like an empty one here, it means that the level is lower and lower. But every time you need to consider that you need to stop the measurement, because if you leave it just like that on the desk, it is just going over and over and over, and the differences won't be visible anymore. So in that case, the companies are prescribing that, or advise you that, hey, can you just do it for 10 minutes and then check it? Because after that, you need to stop the reaction. And in that case, we are using an acidic solution, which is giving you this yellow color, and now it is stable for 2-3 hours. And then you can measure the absorbencies of this one. And based on the manual of the ELISA, it can be like 2 or 3 different wavelengths that you need to measure the absorbance of these wells. So today I'm going to show you one of my results in which I was using a standard ELISA method, a sandwich one. So in my case, if it's a higher absorbance, it means that it is a higher value regarding to the protein of interest. On the practice, what we did, that was an indirect competitive one. So in that sense, that was like, if it's empty, it shows that there is a high level of the protein of interest. So now I'm going to show you the other one. Now you see that For example, here I measured the Elisa full plate. So this is my plate map in which I was using not sexually transmitted diseases. This is the standard values. I have some positive controls as well, and also these were my samples. So when the machine is measuring this one, every time it's important to see that you would have two values. In my case, the manual said that I need to measure it at 450 and 550 as well. These values are like just the background. And the first step in all of the ELISAs that you need to take out the background. So what I'm going to do now is just, I'm going to take out the background value from each of the, as you see here, for example. So if you do like one by one by one by one, then obviously you can have like the same as you see values, but afterwards you don't need these ones, like, because it is not related to any of these one. So I'm going to delete. I said I'm just going to delete these values. So after you clean up your table, you need to remove the blank spaces. And now this is how it looks like that you took out the background value for the 550 ones. Usually when I'm making an ELISA, for me, it is important to see in the very beginning, based on the absorbances, how the values will look like. So what I do every time, because this is my standard, I just want to make sure that it is increasing as it was expected or the measurement was done properly. So usually I select these ones, and if you click on the conditional formatting, then there will be a color scales. So I usually use this one, like to see like it is increasing properly and not. And yes, it is increasing. This conditional formatting gives you a chance to visualize the differences by the values with colors. And also here, because these are the samples, I just wanted to make sure that maybe there is something I really need to take a look at it. So I'm going to change, but not the yellow, I mean the green one, because it is the same like the standard one. So I'm going to change more rules. And here you can select that the minimum and the maximum value, how it should look like. In my case, the minimum value would be, let's say this one, and the maximum value will be this one. That's okay. Yes. So basically, based on this one, now I pretty like easy to see that whatever samples are these three, they were like high, and also the others are just less and less. So the next step should be that you need to take the average of the measurements. In my case, I was using triplicates. So these were my triplicates. And in that sense, you need to do the average. And also it is important to see that every time that you are taking the average values, you need to subtract the blank value as well from these ones. So what I'm going to do now is just, take the average values. But, the problem is that if you took the average here in the Excel file, and then you go further with the Graphpad ones, then you need to change the type of the graph and the data sheet. Like you already calculated the values here and here and here. So what I'm going to show you now is to take the average of these values, I mean the blank one, from the sample one. So let's make it. First of all, I'm going to use the average. That's easy. I think you also used this one before. So now it's 0.002. And then I'm going to just copy my values into here. I'm going to transpose it. But as you see now, it says ref, which means that the values are not there. So I'm going to use this paste special one and paste special. I'm going to transpose, but I'm going to use the values because that was the calculation. So every time you need to consider to use this one. Also, I'm going to use this paste special, then transpose, and I need the values, not the formulas. Okay, and let's say I'm going to make another one, this one, for example. Yeah, and paste special, then values and transpose. Okay, so now these are the values that I need. It was like sample 1 and sample 2, whatever. I think that's sample 3. Good. And then I need to take these values out of these ones. So what I'm going to do now is just subtract 0.002 from it. And also from this one. So now these values are the ones that I need to use. But before we get into the Graphpad file, it is important to see that every Elisa is working with the standard because the standard is well known, which means that somebody made a stock concentration of the sample, and then there should be the proper dilution every time. In my case, these are the ones which are the standard concentration. That's what you know from the manual as well. So as you see here, it is increasing gradually until it reaches this 125 picograms per liter. So these are the basic informations you need to have. The corrugated values, which are here, the standard concentration, and the standard absorbances. So now let's go to the Graphpad. So if you open up your Graphpad, in the case of the Graphpad, if you're working with ELISAs, you need to use the X and Y type of graphs. The reason why we are using this one, because based on the X and Y values, you can do the evaluation of your data and the interpolation as well. So in my case, it was 3 different values I made, right? Because that was a triplicate. So I'm going to click here that I just have 3 samples. And then I'm going to create a data sheet. So here what you see that now I have a next title and the title here. But first of all, you need to start with the standard values. So that should be the standard. Okay, so I'm going to copy the values from the standard ones out from the Excel here into the data sheet. And then I'm going to copy also the concentration manner, which I had here. Okay, that's good. Now I have the standard. And based on this one, I'm going to so based on the standard values, you need to make a standard curve. So in advice, I would suggest you to rename this data table back to the standard one. And raw data. Okay, afterwards, if you click on here, now the Graphpad is going to ask you what to want to represent and how it looks like. So in my case, as you see, because there was an increasing manner, now it is written there, all the values. And based on that one, you can choose different ones like this way or this way, but that's not really necessary to change everything. It is totally fine if you just click OK. Now you have a value here. what we discussed before, you need to change the landscape, and also you need to resize the graph to fill up the page. And now you see how it goes. And this is the concentration in that, but it's not interpolated yet. But let's click on this one in Minimover. Let's see how it works. Also, the values are really, and the representation is really thick, so I'm going to change that one to, if you double left click in the body of the graph, you can change all the values. And let's say the thickness should be auto 1, and the size should be, let's say 4 is enough. Let's go ahead. Yeah, okay. Yeah, that was a bit too tiny. And also it is saying that there are some error bars can be shown because it was too tiny the way it is. Also, I'm going to change the axis thickness, what we have learned before. If you double left click in the axis, then you can change the frame and the origin to the auto ones, which is more easy now. Yes, and I would say that these numbers are really high, so I'm going to change these ones as well. I'm going to change the boldness there. Okay, I'm going to move this one a bit away. And also it is not important to get like that thick. I'm going to delete this node because I know that there are some of the values which are the error bars are not visible. But now I need to analyze my data, and that's called interpolation. So the previous practice is what we have. It was about that if these values are decreasing like this way, but it's really important to see that in your case, the way that the Elisa is working, it is written every time on the manual that which type of interpolation or analysis you need to use. In my case, if I click here, the interpolate a standard curve, if I click on it, now I need to choose. For example, the line, the sigmoidal, the asymmetric one, the semilog, hyperbola, and so on and so on and so on. But in my case, it is a basic simple. I just need to find the basic line. So this one, I'm going to click OK. And now it is saying that, you know, there's a best fit value and a best fitting line. So if I go back to my standard curve, the program immediately shows you that it is trying to show the best fitting line. As you see that it goes into the negative one, so I'm going to change this one, double left click in the axis. And I'm going to change to the minimum and the maximum value of the axis. In that sense, I need to remove this sign here, and I'm going to change to the 0, 1 and click OK. Good. That's okay. The error bars are clipped out of the limit. That's not a problem here. And what I wanted to show you that if you want to make it visible, this trend line, you can change the trend line options like the color of it and so on and so on. But today I'm not going to work with this one. It is just to show like, okay, this is the best fitting line. And now I need my values. The values needs to copy it here as well. So if we go back to the Excel file that you made, the calculation, it's just as easy as it looks like. You just copy the values here. In my case, that was sample 1. And there is a problem every time. If you want to type here this sample, it is not going to work because this is the title of the axis. It should be just values. If you want to type the title here, this is the way that you can do it. Sample 1, for example, and then sample 2. And then sample 3. So now let's see how the interpolation works. Because you typed your values there, then the program is automatically trying to determine the values or the concentration of your values. In that sense, the interpolation part it is extended with two other sheets, interpolated X replicates and interpolated X values. If you click on here, the X replicates, now it is said that in the case of sample 1, the interpolated value is just like this. In the case of sample 2, the interpolated values are like these. But in the case of the sample 3, unfortunately, it was not stable enough, and there were some of the values which cannot be interpolated. And that's what it says here. Like, it was not possible to interpolate some of the values because it was not fitting into the linear range of the standard value here. So I would say that if we go down more and more and more, maybe that would be different. So some of the cases, if you take a look at here, your sample tree was these values, or sample tree were these values. And based on that one, I would say that it is something between these. But the problem is that that was not stable enough. So that's why the program does not give you any values by that. But I'm pretty sure that if you put, for example, here another insert, for example, 0.040, but also please consider that this is not the way that you should do. I'm just trying to show you that what happens if you give a value for that one. So this is an artificial value. I just wanted to extend the range just to see like whether you can have these values or not. So if you go back to this interpolation, see, now it is there, which means that even more value you have, even gradual your standard line is, even more chance you have to get the proper ones. Obviously, and of course, you can calculate everything in the Excel manually, which gives you the value for sure. I'm pretty sure about it. But if somebody is asking you to perform with this application, you need to follow this lead. And in that sense, you need to say that that was not proper. In that case, what you can do is just manually change the dilution ratio and measure another set. So extend the standard measurements or whatever. So what you have now, you have three values, sample 1, sample 3, and sample 2. And you just need to represent these things. So what you can do now is just create a new data table. And that would be, in that sense, now group, because now you have three values, and click OK. And that was sample 1, I'm pretty sure, and then sample 2, and then sample 3. Okay, and I'm going to just copy the values what I get from the interpolation. Yeah, these are the interpolated values. I'm just copy these values into this one, and I just paste and transpose. Now I have this one. And let's say, what was that? Insulin level. And now I have the graph, which was made by the program. And I think it's pretty easy to work with this one. And then you can just change to the landscape, resize the graph to fill the page. Then you can remove these ones. And also you can make some management by the axis and the graph appearance. In here, you need to type the ones that the manual says that this is the concentration in picomole, for example. And also you can change the position of these ones. It's up to you how you change now the figure, but this is how we use the Graphpad, for example, Elisa evaluation. I'm going to show you another type of Elisa. in which I'm going to use now the file open function. And let's say that should be goes with the Elisa. That was a competitive one. In here, as you see, these were the absorbances. And as you see, if I have a high concentration that was really low compared to the low absorbances, I mean the low concentration and the high absorbances. And then I put my data here, and then there was the interpolation. So these were the first of the values, which were, in my case, that was sigmoidal. And I'm going to take a look at the graph, how it looks like. Let's see, resize the graph. So this is how my measurement looked like that time. And from that one, I interpolated the values here, as you see. Still have some values which were unable to determine the values, but I still have some. And then I just copy the mean values for the graph, or even like the values what I get from the measurement. And then I made a figure which looks like this. So in that case, it's really important to see that if you have, for example, here the row absorbances and the interpolation, if you take a look at the list, every time you need to use the one which the manual says. So if you have a basic ELISA, then usually that should be the line one. Or even without the ELISA, if you just want to determine the protein concentration, you can also work with the line one. If you are working with a special one, like this competitive type, then you can use the sigmoidal ones. But it is really important to see that the manual, what it says, every time you need to follow that one. So I hope that this time I showed you something new and you work now with Elisa. So good luck with that one. And of course, feel free to ask. Have a nice day. See you guys. Bye bye.